Hello, everyone. Today we are continuing our idea of equality postulates. So the previous day we did reflexive, substitution, and addition. Today we're going to talk about subtraction. So subtraction is if two equal quantities are subtracted, they form equal quantities. So I want to take what we have in our given here, which is A equals B and C equals D, and I want to subtract these, and this should be a 1. So I'm going to say A minus C is equal to B minus D. And our reason there is subtraction. So then if we look at this example here, we know that DAC, which is this line, that angle, is equal to ECA, which is this line. And we know that angle 1 is equal to angle 2. So if I look at this, what I want to think about is the fact that if I took this purple line and subtracted that green angle, I would get angle 3. And if I took the blue line and I subtracted the pink angle, I'm going to get angle 4. So that's what I want to do. So step 1 is to write my givens. Step 2 is I'm going to say angle DAC minus the measure of angle 1, subtracting the left, is equal to, I'm going to subtract the right, measure of angle ECA minus the measure of angle 2. And my reason there is subtraction, because that's what I did. And now when we looked at that, we said that if we did the line minus angle 1, we would get angle 3. So that means the measure of angle 3 is equal, if we did the blue line minus the pink, we got measure of angle 4, and that's substitution. So now we're going to do another example here. So, our example, DF is equal to BE. So notice that they both overlap here from FD. And I want to prove the little parts are equal. So I have my big one. Notice this overlap. This overlap's important because I next want to say that overlap's equal. So EF is congruent to EF. And that's going to be reflexive because I always need two equations to add or subtract. And now if I look at this, DF is this green. If I take the green and subtract the overlap, I get DE, which is what I want. So I'm going to do that subtraction. So I'm going to say DF minus EF is equal to BE minus EF. And that's subtraction. Next, I'm going to do the substitution because in my diagram, if I take the green and I subtract the blue, I just get DE. So DE is congruent to BF because if I subtract EF from BE, I get just BF, and that's substitution. Our last theorem that we're going to do in this section is halves of equal quantities are equal. So if I look at what I know up here, I know AB is congruent to DC. So I know this long line is equal to this long line. And I know AF is half and EC is half of it. Well, that means that AF is congruent to EC. And our reason is halves of equal quantities are equal. So I'm going to have you do this last example. Actually, we'll do this last example together on the video. I want you to pause and give it a try on your own and come back and see how you made out compared to me. So hopefully you paused and tried. So I know that angle R is congruent to angle F, or that's what I'm trying to prove. That's what I want to prove. My givens are down here. So I know that CA bisects DCB, which means it cuts it into two equal halves. So being that CA bisects DCB, that means the angle S equals half of angle DCB. Because I know that CA bisects DCB, so that means S is half. And then I also know that CA bisects DAB, which means angle R is half of angle DAB. And the reason for that is definition of bisect. Bisect makes two equal parts or cuts it in half. Now that we did definition of bisect, we also know that the two big angles are equal. So if I know the two big angles are equal, I can say angle S is congruent to angle R, and that's because halves of equal quantities are equal. And then we're going to work on more of these in class during our classwork. If you have any questions, please write them down.